So let's talk about renewable energy sources. So we can harness energy from the sun, wind, water, ground temperature, and biomass. What kind of energy can we get? We can get electricity, we can get fuel for vehicles, and we can get energy for heating and cooling. So getting back to generating electricity, quick recap, something needs to turn a turbine, and when the turbine turns, it generates electricity. So turbines can be turned by steam, flowing water, or wind. And we have already talked about how steam can be generated by burning coal to boil water or through nuclear fission, which produces heat to boil water. One more way that we have not discussed is by using the Earth's natural heat, which produces natural steam from underground geysers and hot springs. So wind energy uses the blowing wind to turn the turbine. So you might have seen windmills around in windy areas, like if you drive towards Chicago, you'll see a lot of these. What this does is the blowing wind turns this fan, and when this fan turns, the turbine inside this unit turns, and that generates electricity. Hydroelectricity uses flowing water. So if you have a good fast river, what we do is build a dam so that a lot of water collects in the reservoir behind the dam, and then allow water to flow from the dam at a very high speed, and when that water flows at a high rate, it turns a turbine, and when the turbine turns, the power is generated in the powerhouse and electricity is distributed. Geothermal energy uses naturally produced heat and steam from under the ground. So in some areas where the magma is close to an underground water source, the magma heats the groundwater, and when the groundwater is heated to a high temperature, it produces steam. We can tap into the steam, so we can put pipes down which let the steam up through the pipe and into a unit that has a turbine, and this steam, this naturally produced steam, turns the turbine, which then produces electricity. So these are all different ways in which we can use the energy from nature to turn a turbine and generate electricity. There are benefits and drawbacks. EROI can sometimes be pretty high for some of these forms of renewable energy. It can be pretty efficient. Wind energy has an EROI of 23:1, which means for every unit of energy invested, we get back 23 units of energy. Hydroelectricity has EROI of 10:1. For every unit of energy invested, we get 10 units of energy. Geothermal energy, depending on where we are using it, can be pretty low, 2:1, to pretty high, 20:1. And compare this with nuclear power and coal power. Nuclear power has an EROI of 16:1. For every unit of energy invested, we get 16 units of electricity. And for every unit of energy invested for a coal-powered plant, we get 11 units of electricity. These renewable energy sources are clean because their emissions are negligible. They are not going to run out because they are renewable, because the earth keeps generating the source of energy, and they create a lot of green collar jobs. Green collar jobs are jobs which are dedicated towards clean energy. The drawback is that it is not possible everywhere. You cannot dam rivers everywhere. The damming of rivers and submerging of land is not something you can do anywhere and everywhere. Geothermal steam is not available everywhere. It is found only in regions where the magma is close enough to the groundwater source. And wind speed needs to be very high for wind energy to be produced, and wind varies from time to time and from place to place. Hydroelectricity has some other problems associated with it. When you dam a river and submerge a large amount of land, it destroys habitats by submerging habitats underwater. And it disrupts the natural flooding cycles of rivers. And it affects a lot of species that are dependent on flowing rivers by creating lakes and preventing animals that are dependent on rivers to be dependent on their natural habitat. And wind energy has some problems where the turbines, which are so high up in the air, can threaten birds and bats that fly at those heights. And the biggest drawback is the cost of research and development, and we do not have enough funds being invested into the research and development of these sources of energy. This is a map of wind power generated at different parts of the US. So naturally, in areas that are mountainous, there is a lot of wind. However, a lot of regions have practically no wind power, and the Midwest has a decent amount of wind. And we know that Chicago is called the Windy City. There is plenty of wind near the Great Lakes. And if you go by state, the wind power capacity or the ability of that state to generate wind power varies depending on whether there is lots of wind or no wind in that region. For example, Kentucky can produce literally zero amount of wind power because we have no wind at all. It seems like it's a pretty windy place and the umbrellas all turn inside out when it rains, but really that wind is really negligible when we are considering the amount of wind needed to generate wind power. One more type of renewable energy source is solar power. This is a type of power, pay attention here, that does not require the turning of a turbine. Okay, so you want to pay attention here. It is the source of generating electricity that does not require the turning of a turbine. So then how is electricity generated? Well, I thought electricity had to be generated when a turbine turned. Not necessarily. Solar power taps into a different form of generating electricity. It uses what is known as photovoltaic cells. You might have seen panels like these. These are solar panels. Each panel is made up of tiny circles. Each circle is a photovoltaic cell. What is that photovoltaic cell? This is the close-up of a photovoltaic cell. It has two types of let's say substances. Okay, you don't need to know the details of this, just two types of materials. And what happens is sunlight hits this photovoltaic cell, and when the sunlight hits the photovoltaic cell, it generates electricity directly because there is a plate made of silicon in this photovoltaic cell. When sunlight hits the silicon, it releases an electron. When electrons are released, it is attracted to the opposite plate. So there are oppositely charged plates, a negative and a positive. The electrons are attracted to the opposite plate. And when these electrons flow to the opposite plate, electric current is generated. That's basically how an electric current generates, by flowing of electrons. So what is the benefit of solar power? It uses no fuels, it's very quiet, very safe, contains no moving parts, and requires very little maintenance. They emit no greenhouse gases or air pollution when they are up and running. And they also allow local and decentralized control over power. So local people can have control over their own power. Individual people can have power over their own, or have control, can have control over the power they generate for their house. This is extremely helpful, particularly so in developing nations where electricity is such a problem. In more developed nations, like in the United States, people who own solar power panels or photovoltaic cells, they can generate electricity for their own house, and then they can even sell the excess electricity that they generate back to their local power utility. It's called feeding back into the grid. They can feed excess energy back into the grid. Green-collar jobs are created. These are jobs that are focused on designing, installation, maintenance, and management of renewable energy technologies. So we have more of these kinds of jobs, and solar power industries are really creating more jobs. So this is a massive solar power field in an airport in India, and it is supposed to generate enough and more power to run the entire airport. These are solar panels on the roof of greenhouses in China. So you can see how much electricity might be generated there. Solar panels on the roof of trains to generate electricity for running the trains. And solar power panels, tiny little panels for individual huts in Africa to generate a little bit of electricity for every little hut. So you can see how, especially with little solar panels like this, individuals can have control over their own power and not depend on governments to provide them with power sources. There are, of course, drawbacks. If there were not drawbacks, we would all be using solar power. Not all regions are sunny enough for solar energy. So obviously for solar energy, there needs to be plenty of sun. And all the daily and seasonal variation in the amount of sunlight available poses a lot of problems. This is the amount of solar radiation in different parts of the US, and there are some regions that receive plenty of radiation, and these are regions where lots of solar power panels are being set up. Solar power also produces the most expensive electricity. However, with more and more research and development going into it, prices have dropped over time and efficiency has increased. So you can see that prices, though still high, of solar energy has been dropping, and production has been increasing steadily as efficiency increases. What else do we use fossil fuels for? Don't forget that we use fossil fuels not only for generating electricity but also for powering motorized vehicles, for heating and cooking, and for making many products from petroleum. So let's talk about energy used for powering motorized vehicles, which is what we use fossil fuels for. An alternate or a renewable alternative is biofuels. Biofuels are fuels made out of biomass or plant matter, and this one form is ethanol. Ethanol is basically an alcohol, which is a biofuel made by fermenting carbohydrate-rich crops. So you get ethanol, which is an alcohol, by fermenting any kind of carbohydrate-rich source. And we use corn because it is very rich in carbohydrates. It can be added to regular gasoline to reduce the emissions. So there are some vehicles which are flexible fuel vehicles. They run on a fuel called E85. What that is 85% ethanol and 15% gasoline. So you can see that by reducing the amount of gasoline used by 85%, we are going to reduce a lot of the noxious emissions released by gasoline. Biodiesel is another type of biofuel. This is produced, it's a type of diesel that is produced from oils like vegetable oil, cooking grease, or animal fat, but mostly it is used from soybeans, oil palms, and rapeseed, which produce a lot of oil. Biodiesel also reduces emissions and its fuel economy is pretty good. It costs just a little bit more than gasoline. However, not all scientists are very pumped about biofuels because they say it's not that sustainable. The reason is that you need to grow crops for biofuels, and growing crops means industrial kind of agriculture, and we know the problems of industrial agriculture. It impacts ecosystems via increased pesticides, fertilizers, irrigation. There's a lot of fossil fuels used for growing the crops and harvesting, and it takes up precious land that could have been used for other things. And growing crops for biofuel competes with growing crops for food, and that makes the prices of food go up higher. So this is an infographic about whether we should be growing crops for food or for fuel. And basically it tells us that 8 bushels of corn can be used for generating 21.6 gallons of ethanol fuel, or enough food to feed a person for a whole year. How far does 21.6 gallons of ethanol drive us? So we have to consider whether that 8 bushels of corn is better used for fuel or for feeding people. And this is one of the major reasons why scientists are not very happy with biofuel. It says that nearly 1 billion people will go hungry because 5 billion bushels of corn is being turned into ethanol. That 5 billion bushels of corn is enough to feed 412 million people for an entire year. So what is the future of power generation? Nations are looking for ways to move away from fossil fuels because that is what we need to do. We don't have much fossil fuels remaining, and fossil fuels generate so much pollution and so much environmental impacts that we really need to get away from it. However, we need a reliable energy supply because of our lifestyle today. Nuclear energy is the main non-renewable alternative to fossil fuels, but that also we know comes with a lot of drawbacks. So what should we do? Governments need to move towards more renewable sources of energy. There is no two ways about it. We need to be investing funds into developing technology, into research and development for making technology that makes these renewable energy sources more efficient, inexpensive, and more reliable. As of now, we are unable to depend on renewable energy sources because they are not efficient enough, they are expensive, and they are not entirely reliable. We need to work on making it more dependable. And we have to keep in mind that the amount of fossil fuel that is left on the planet is fast declining. Coal is fast declining in Kentucky. Oil all over the world is fast declining. So within a generation, we are going to have not enough fossil fuels. If we continue to depend on fossil fuels, life is going to be extremely expensive, and it's going to lead to a lot of economic and social problems the world over.